Alrighty. Yeah. All right, so we're gonna cover associations, and associations is just relationships. So we've already done this before. When you design a database and you want to model an application, you have a bunch of tables, and then you connect those tables. So we've done that a whole bunch at this point. So Django has a way of expressing that, but ultimately it's just going to end up as SQL. So that those relationships between tables, like what are the kinds of relationships you can have?
One-to-one, many-to-one, and one-to-many. Or I
Yeah,
messed up the last one.
yeah. So the last one is many to many. So the
Uh,
many to one and one to many are it's the same. It's just the reverse. But yeah, cool. All right. So first off, I'm gonna go get this starter code application done, and it's end of day 3 branch. So I'm gonna clone this down. Great. Clone. Okay. And I'm gonna CD into it and then open it. Okay, and it told me that I want to be on the end of day 3 branch. So how do I handle that?
You type get branch to see
Okay.
what you have. Um, how do you look at all the branches? Does it get log?
Yeah, that's a good question. Actually, I'm not sure what command you could use to see all of the branches. Yeah, I'm gonna look that up.
Is it get branch with the attack A?
Okay.
Okay.
Thank you very much. So what kind of menu is this? So I have a colon at the bottom. And I can use my up arrow. Have we seen any other thing like this in the terminal?
In SQL, right?
Yeah, so yeah, in the SQL terminal, if you write a query and you get a bunch of results and there's like more results than fit on the current screen, yeah. So
Input?
yeah, so this is actually called like a stream. So we're kind of streaming the data and other things. So to get out of this, typically you'll press Q. And then you can do the same thing, like for example, less. This is a way to like read the contents of a file without, you kind of open it as a stream and then you can close it. So less, and if I do requirements.txt, so it's the same thing. I press Q. So there's a pretty similar API for things like that. Okay, so I have these branches right here. So I'm gonna check out this branch. So how do I get on the end of day 3 branch?
Just get checkout and then the branch name.
Yep. Okay. So now I'm on this branch and I can take a look. So can someone talk to me about the structure of everything that's going on? I've never seen this before. So what's happening?
Hey, real quick, Chad. Sorry, before you got to the git checkout end of day 3. What was that previous command?
Less. So it's just a way to stream the contents of a file. So if I did, for example, cat requirements.txt, it's gonna print out everything to the terminal.
Oh yeah, I didn't mean. I think I meant the one before less. Sorry.
Oh, that was git branch -a, I think.
Git branch dash
-a.
and it shows all the branches. Okay, yeah. Thank you.
I didn't know about that one. Okay, cool. So why don't we start with the requirements? So I'm gonna ask, we got a lot of breakfast eaters. I'm gonna ask how about Joyce? What is the requirements.txt file and why does it exist?
Sorry, can you hear me now?
Yes, yeah.
Oh, I'm not eating breakfast, but
Oh, that's fine. Yeah, I'm not like, that wasn't a criticism. I just didn't want to call on.
yeah, so requirements.txt is basically all the dependencies that you need to run this Docker. And that's the version that's freeze on this for this Docker.
Okay.
Did I answer all your question?
Yeah. So yeah, we're talking about Docker. So is the requirements.txt specific to Docker? Anyone can answer.
No.
Yeah, it's for your application, right? The dependencies to run whatever code you have in there.
Yeah, so the requirements describes all of the Python third-party dependencies that this application requires. And if I'm running this in a container, or I'm just running it locally on my machine, or if I'm running it, in a virtual environment on my local machine, you would still want to have a requirements.txt file. So here we're specifying exact version numbers. You can also do like, I forget if it's, I don't think it's this syntax exactly, but you can basically specify, at least this version or greater, less than this version, and so on. So typically what you'll see when you create a requirements.txt is this, like, you have to have exactly this version of this and exactly this version of this, but there's also ways to be more flexible. There's also ways to be even more strict. We're not gonna get into it, but once you like move into large production Python applications, you're typically going to want to have something that's even more specific. So there's something called like a piplock file, which is actually very similar to how Node, when you create a Node project and you have your packages.json, it actually will be it's a full description of the exact like hash of the source code that you're using. So it's just a way to be even more specific, but we don't need to worry about that right now. You probably don't need to worry about it. Depending on what you're doing, like in your personal projects, you may encounter some issue that forces you to do that. Okay, cool. So requirements, and then what's happening here? I'm gonna ask Chris, what is the Docker Compose file?
It looks like it's setting up the database and running a container for that database. It looks like there's a volume to persist that database into the Django project.
Okay, cool. Yeah, so can you tell me more about what a volume is?
I think it's some kind of separate separate folder that's kind of local. So whenever you make updates to your database, it'll save it.
Yeah.
Yeah.
Yep. So I think that's right. So a volume in Docker, lingo, or in the Docker universe is, so typically when you create a container, you can create an image which defines your application and all of the dependencies and everything you need, and then you run it. And when you run it, it only exists for, it only exists while it's running. And if, so let me just run something real quick. Let me find what is that thing called? Disney box. So I'm gonna go, this is just a random image, is like a Unix utilities kind of thing. So I'm gonna grab this. I'm gonna go here. I'm just gonna pull this down. Okay, pretty small image. That's why it's so cool. And then Docker images. Okay, so I've got this BusyBox container. So now I want to run it. So to run it, Docker run, and I just want to go in there and see what's happening. So I'll connect the terminal, and if that's bashing it, we'll see. It's not. Let's try sh. Okay, so now I'm in the terminal. I can do ls blah blah blah. I could try doing touch. Let's see if it has there vi. It does. So now I'm gonna just create a quick file. So I'll insert -i and then escape :wq. I'm gonna save it. And if I do ls, I can see that my file is there. And I could read it in and see if we have less. We do. So now we have this file there, and what happens is, so I've just created a file and saved it right in this container. Now if I exit, let's do exit. Docker ps Docker ps -a, and yeah, here's the one that I had just closed out of. So I'm just going to go ahead and Docker rm that. So I pulled down an image, and I still have the image, and then I ran it. So I created an instance, like a running instance of the container, and I saved the file. I created a file and saved it. So now if I run this again, am I going to have that file there?
No.
No.
Yeah, well, let's see. So ls, that file is not there. So the whole point of Docker containers is to create these ephemeral, disposable virtual machines, basically. But sometimes you do want to save it. Sometimes you want to do stuff, and then you want to save it, and then I want to save a file, and then I want maybe my container to go down and come back up for whatever reason, but I also want to hold on to that file that I created. So what Docker Volumes allows you to do is to create a little connection. So just like you do port mapping, right? So if you run a container with port mapping, you can provide a way to access the container from your host machine. So if I run a container and I do port mapping, like for example, we're doing right here, I'm saying I want to create a little pathway that goes from my local machine into the container. And a volume is basically the same thing, except instead of being a port that you keep open or a port that you can map, it's a file that you map, basically. So a volume is basically just, I have, Docker will manage the specifics, but somewhere on my local machine, Docker is going to create a directory, and then it's going to map that directory to somewhere inside of your container. So anytime you save something to that directory in the container, it will actually save it on your local machine. And so if you spin down the container and spin up a new one, it can still go in, it has a way to access that file that you saved. So you can persist stuff across container sessions, basically.
Can you only do this in a Docker Compose file, or can you do it in a regular Docker file as well?
You can't do it in a Docker file, but you can specify it when you run a container. So there's an option, you can do Docker run -v. So you can definitely do that without using Docker Compose, but it doesn't happen in the Docker file itself.
Cool.
Do you have to create the volume, or if that like path doesn't exist, will it create it and just make one for you?
Yes.
Okay.
Yeah, so there are actually a few, we don't have to worry about it, but there's actually a few different kinds of volumes. Here we're doing the kind where we let Docker basically manage everything. So it's gonna pick somewhere on your local machine, and it's gonna keep track of associating this name with that file path.
That makes sense. Thanks.
Okay, cool. So this Docker Compose file, this is gonna allow us to run a database, and then we can persist whatever data we save across sessions. So if we create a database table and save a bunch of data to it, and then we decide, we're going to spin down the container, then spin it back up, that data will still be there. All right, cool. And then we have the project and the app. What's the difference between a Django project and a Django app?
You can have multiple apps on a project. So basically the project's the core files, as you see, like the settings and everything. And then you can have multiple apps within that.
Okay, yeah, exactly. So the project is the top layer, the top level of organization, and then you can have you can actually have 0 apps, but you can have 0 or many apps. All right, so we've got this settings file. Let's see. Corey, can you tell me about the settings file?
No, it's all the project settings. It's where you like for instance, you have the installed apps, a list of installed apps. You have the list of the database, how it interacts with the database,
Okay.
and all that kind of sort of
Yeah.
user admin type stuff.
Okay. Yeah. We'll most of this stuff is just going to be, we just leave it alone, but there are a few things that we might change or add later on. So this database connection. So how do I know that this is right? Like, where does this information come from?
It's generated automatically. So some of that might come from the Docker Compose, but
Okay. Good. So
it's already changed in there, but sometimes I think when it spins it up initially, doesn't it default to whatever the the Docker default is, so you have to check it, make sure it's like the same database, same password, that sort of stuff,
Okay,
that you're actually working with.
good,
Okay.
yeah. Yes, so you what's in here, so I'll say a couple things. One is that when you just start, if you start a brand new Django project, the default database will be a SQLite database. So you won't have this exactly, it'll be, you'll have this databases field, but it'll have a different engine. It'll have a SQLite engine, and it won't have any of this other stuff there. Because it doesn't automatically know what your username and password and everything else is going to be. So this information has to match whatever our database is. So we are using, in this case, this Postgres database here. So this port has to line up with what? Why are we not using 5432? I mean, Postgres runs on 5432, so why are we not saying 5432 here?
Because it probably won't work. It'll Postgres is using that, but you want to I guess not clog the machine, for lack of a better word. Not clog the ports.
Okay. Yeah,
I think
so
it's because
go ahead. Yeah.
Isn't the 5454 the port that's getting exposed from the database container? And then that's what we're trying to talk to.
Yeah, so we have to keep in mind how we're running this. So our database is running in a container, but for the moment, we're running our Django application on just our boring old laptop, right? So we're running the Python application on the host machine, and we're running our database in a container. So if you want something on the host machine to talk to something in a container, you have to use port mapping. And here, this is the port on the local machine that will be mapped onto the internal port in the container. So that's why we have to use 5454.
I think Docker should have flipped it. Intuitively, I think like it should be 4 or 5, 4, and 3, 2, 2,
Yep.
5, 4, 5, 4.
Yep.
So it always
I
confuses
think
me.
the same thing. It is confusing. I've eventually, with enough time, I've just accepted it, but it is the opposite of what I would expect it to be. Which is
Yeah.
one reason why I always make sure to use a different port, because it helps me keep it straight. If it's the same one, then it's just like, So it's kind of a yeah. So, but also what Corey mentioned about not clogging the ports. If you have Postgres running locally on 5432, I think that this port mapping will override that, but just as a way of eliminating the possibility of accidentally connecting to your local Postgres instance.
So if you were not gonna Dockerize this, would you just have 5432 in the settings file?
Yeah. So if I were just using a Postgres database on my host machine, then I would use 5432 here.
Cool.
Okay. So yeah, the basic idea is that whatever you have here has to match whatever you have here. Okay, cool. And then there's some other stuff that we'll look at as time goes on. Okay, cool. So I think that's that should be good, basically. All right, so in order to actually start using this, what do I have to do? So I have this application, I just, pulling everything down. Now I want to start using it.
Install the dependencies.
Okay, cool. So I have dependencies here. So before I install dependencies, What should I do?
Create a venv and then install them.
Yeah. So do you have to create a virtual environment?
You don't need to, but by like creating one for each project, it keeps everything like together so that like you don't accidentally change a dependency and not know. And I think they can exist anywhere if I understood it correctly. And it's like when you create one, it doesn't really matter where it's at, but when you update the dependencies, that's what you're trying to avoid by creating a new one with each project.
Yeah, good. So creating a virtual environment has a couple of benefits. One of them is isolating projects. So I can, I can install a project, I can install everything that it needs, and then I know that this project in this virtual environment only has the Python dependencies that it needs. So one thing that can happen if you don't use a virtual environment, for a while it'll be fine. You won't have any problem. You can just install stuff globally on your machine. But eventually, and I can tell you this from experience, you're going to start running into weird dependency issues that are very hard to diagnose. Because you've got 30 different versions of X, application. It just ends up being a huge mess. So to keep things isolated and clean, and because you really don't need, do you need, do you need SQL parse globally installed on your laptop? Probably not. Okay, so I'll create a virtual environment, and you do that with Python -mvenv, and then you can call the folder whatever you want. I'll just call it env. And that should show up here. There it is. And if this is not grayed out, you want to look in your git ignore, because it's not the end of the world, but you don't want to be pushing up stuff like this to GitHub. Okay, so now I can install everything, right?
You haven't activated it yet.
Yeah. So you have to make sure you activate it, otherwise it's not going to do you any good. So source vent bin activate. Okay, so now I can, depending on how you have your shell set up, you may or may not see something like this. Okay, so now I'm in my virtual environment. So now I'm going to install everything in the requirements.txt. And there's a shortcut, so Python dash, sorry, click install -r requirements.txt. So it's going to go through and install everything that I have described in the requirements.txt.
Not to slow things down, but
Sure.
How do you know you need all these dependencies? Like I get the scicop
Yeah.
but not like the typing extension and the SQL parse. Will Django just not work without those?
Yeah, so that's a great question. So in order to generate, so let me, I'm gonna delete this virtual environment. So I'm gonna do deactivate then, and then I'm gonna recreate one. So I'm gonna create a fresh one. So the answer is you won't necessarily know. So the requirements.txt contains direct dependencies and then also indirect dependencies. So dependencies of dependencies. So you won't really know what those are necessarily. But how you get to this point is, well, I know I need Django. So pip install. First off, I'm going to do pip list. This will show me everything that I have, all the Python packages that I have in my, virtual environment. So I've got pip, which just, you always have, and you always have setup tools. All right, so I'm gonna do pip install Django, and I'm not specifying a version, so it's just gonna grab the latest one. So we'll see what the latest one is. It's maybe 4.3 by now, 4.2.4, something. And notice here that it's collecting Django, blah, 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 and then also collecting ASCII ref and SQL parse and so on. So if I do pip list now,
Okay, so some of those just come as default when you're installing Django.
yeah, so I explicitly installed Django, but Django needs this and this. And then I also install scopg. I may have installed the binary, but I'll just do so pip install scopg. I don't know if it will. Let's see what we get. So pip list. So I think I installed the binary. It should, you know, it's
So
a
it looks like when you installed scopg, it also installed typing extensions.
yeah.
Okay, cool. Yeah, I was wondering where all those random ones came from, but now it makes sense.
Yeah, they're just dependencies of dependencies.
Cool.
Question.
So this is, by the way, real quick, this is another reason why more sophisticated dependency management tools like Poetry exist. But yes, go ahead.
So I was gonna ask, did you just install those manually right now, but you could have used the text file to install them all in a row, or do you have to install them manually like that?
Yeah, that's a good question. So, you know, what I just did was I'm like in developer mode, right? So I'm writing some code. I write some code. Oh, I think I should use this other dependency to help me do this. I install a new dependency, blah, blah, blah. And then when I'm done with everything and I'm ready to like push it up somewhere, that's when I would generate the requirements.txt file based on whatever I happen to have locally. So that's when you would do like pip freeze and then redirect the output. So pip freeze is the same thing as pip list basically. And then requirements.txt. So I would generate the requirements.txt file based on whatever I had installed as I was developing.
So that is what that command does. Like I've done that. I don't know what I did. Now I know what it means.
Yeah, so pip freeze, it's the same thing as this basically, but minus the default stuff like pip. And it also is in this format.
So does it get saved to the environment folder or
Yeah.
in the
So if you
Django?
dig around in here, you really never need to do this, but if you dig around here, this is literally the source code. It's like you've gone to GitHub and cloned down all of the repos that you need. So if you go here, this is, so here's Django. Here's the actual Django source code right here. Find anything interesting here. But yeah, this is Django source code. Okay. All right, so I'm actually I'll just undo this real quick. So yeah, delete and then remove that. I'll recreate it. You could also like, uninstall everything, but this is the lazy man way of doing it. So activate. Okay, so I'm just installing all of the dependencies that are in this requirements.txt. Another thing to note, I don't think any of you have encountered this, but another reason to use like a more sophisticated dependency management tool is that the version of Python also makes a difference. So you want to specify like, okay, this code works under the following conditions. If you have Python 3.9 installed and you have, XYZ dependencies installed, then this should work. So if you have, an earlier version of Python, there's a good chance that you're going to have an issue with some of this stuff. Okay, cool. So we've got this going. So I've got all my dependencies installed. So now I'm going to need to run. The database. How do I run this database?
Docker compose up.
Yep.
/d.
So I can do Docker compose up, or I can add the -d flag and it will run as a background process. So I'll do this. Okay. And then once I have the database up, I have a fresh, clean database, and then I have looks like some source code, and then I have in my models. Let's see. Noel, can you tell me about a model, Django model?
So that's basically building your tables in your database. So like Pokemon would be the name of the table.
Okay.
And then like name, level, date encounter, that would be each row. Or that'd be each column.
Yeah, exactly.
And then you put validators and like max length just to like narrow down what it is. And then you have your methods underneath.
Yeah, cool, exactly. This is another the layout. You said rows here, and this is also another like it's kind of conceptually confusing because you would want this to be like turned, right? Because columns go up and down, but Python doesn't work that way, obviously. So yeah, so this is a column, this is a column, this is a column, this is a column. And there's a whole bunch of things you can do, depending on what the specifics of the field. And again, this is all just wrapper. So this is going to become a SQL table. Even though we have all this Python code, this is just going to become SQL. So how do I make it actually exist? So it's not a clear question. So I have a database running, but it's just a fresh, clean database. And now I have a description of this SQL stuff that I want to exist in the database. How do I make it?
You have to create an instance of it.
Okay. So you don't you don't actually have to do that. Django will manage all that stuff.
You need to migrate it.
Yes. So the way you apply this Django model to actually create something in the database is by using migrate command. So there are two steps to this. So I'll do the first one. So Python -m, or was it Python? Sorry, Python manage.py make migrations. So can anyone describe what just happened?
you're like staging SQL that's gonna get sent to the database, and then you can see what it's gonna try and send. Well, I guess it's like more how it's configured, but if you look at the migration 001, it'll have pretty much like what's staged. And I think there's a way to use like SQL migrations with like Pokemon app and then like 0001, and you can like see the SQL that it would try to send to create everything.
Yeah. Yeah, I don't know that command offhand, but yeah, so this is, notice like this and then look at the model as well.
Is it me, or does it look like a JSON type of file now?
Yeah, it does look like JSON. So we have this other class. Let me try to move this, make this a little smaller. So we have our class. So this is like from a user perspective, like as a developer, I'm writing Django code. This is what we write. But Django will take this, and on the way to actually creating SQL, because that's what this will become eventually, this will become SQL, is this intermediate phase, which should look familiar to this, right? So we have name, it's a car field. We have this migration class, initial true dependencies, operations. And this, you don't have to know anything about this, but the name is Pokemon. So maybe that's the table name or something. Fields. These are the fields. So ID. Notice that we didn't specify an ID field, right? So Django by default will provide everything within an ID field, and it's a big auto field, which is gonna be end up being the same thing as the serial. So it's like serial primary key. When you create a table. And we have name, it's a car field, blah, blah, blah. So anyway, we have all this stuff here, which is kind of a next level, lower level representation. And this is something that we can actually save. We can save this file and we can check it into our code base. So we're not really going to worry about it, but database migrations, this is like changes in your database schema. So this is something that can be a pain to manage, but it's important to do that. And Django provides a default way of doing that. So if, I write this application and then, a year later I decide, I want to add another field here. You have to update the database.
So if I wanted to add in the class like battery level, right? And I add that, then I will have to do the migration again. So that's what updates the SQL.
Yeah, so migration just means change to the database schema. So if you are updating or changing the database schema, not like adding a row, but updating the schema itself, then you run a migration. Okay, so that's what that is. So this is, and if I were to add a table and run another migration, you would see 002, etc. Okay, so is this in my database now?
Not until you migrate.
Yeah. So this kind of creates an intermediate file that you can check in to your GitHub repo, so you can track the state of your database, but it hasn't actually executed any SQL against our database. So Python manage.py migrate, and we get a whole bunch more output. And all of this stuff is the default Django stuff. you don't really need to worry about any of this, but the reason why there's so much here is because this is all the default Django apps. What you did, or what we did right here is this Pokemon app. So here's the migration. It applied Pokemon app.001 initial, which is this file right here. All right, so now this database should actually have stuff in there. So there's a few ways we could check that. One way is to just go into the database itself. So I can do docker ps. I can grab it, or actually I should be able to use psql dash h local host dash u. We'll look at the credentials over here. Okay, so and then the user Postgres and the ports 5454. Let's see if this works. All right, so I'm in this database, but I actually don't want to be in this database. I want to be in Pokedex DB. So I can describe this. There's nothing there, so I'm gonna exit. And I'm gonna add a -d flag for the database, and that will be Pokedex DB. Okay, so now I'm in this. So one, this database exists. So it didn't exist before, but we ran the migration. It exists. So if I describe this, I can see that there are a whole bunch of tables, and all these tables come from the default Django migrations that we just ran. And again, this is the same streaming file format, like less or a lot of other stuff. So I can do the down arrow. And I can see at the end that I've got Pokemon app Pokemon. So we called our model just Pokemon, but Django has its own kind of, lower level conventions for creating the actual table. So the actual table name is Pokemon app Pokemon. And we can query that. We can do select star from this. And there's nothing there. We haven't added anything, but we can see that these fields do exist. One, there's ID, which we didn't explicitly add here, but Django automatically adds. Name, level, date encountered, captured, etc. So I just want to point that out that, there isn't just a one-to-one correspondence between what you're doing in Django and what ends up being in the database. But yeah, so just so you're aware of that. It shouldn't really be an issue, but okay, cool. So that looks like the migration worked. So I'm gonna exit out of this. Okay. So now I think everything is set up now, should be good. So let's go ahead and actually, let's take a break. We'll take a break and then we'll go through the actual lesson. So 10 minutes. All right, cool. So we're gonna, we've just seen the application just as a whole, and then we have one model, the Pokemon model, and we checked in the database so we can see that it actually exists. So now what we want to do is we want to create another model or another database table and then connect those two things together. So we already know how to do that in raw SQL, and we're just going to look at how we do that in Django. Okay, so the first thing we do is we're going to create a new app. You don't really have to do this, and it kind of depends on how everything is structured. So we're going to end up creating a moves table. We have a Pokemon table, and now we're going to add a moves table, and those two are going to be connected. So if the moves stuff is used, elsewhere in the app or is used by other apps, then putting it in its own separate thing could be a good idea. If it's not, then you could just throw that, you could add that into what we already have. So you can have more than one model here in this like models.py. You can have as many models as you want in a given app. But the way we're doing it today, in part just for the sake of showing you how to create multiple apps, we're going to put it in a different app. So we're going to create this app right here. So everything is set up and running, should be good. So I'm going to create this app. So Python manage.py start app and then the name, and we get all this default stuff. So we have views, which we're not going to worry about yet, but this will be like the actual API, which we'll see later. And then models, which we will care about for now. All right. So we just added a new app. So we're gonna basically let Django, let the application as a whole know that there's a new app. So we go into settings.py, which is over here. We'll add that. You can add a trailing comma if you like, but no, you don't have to. All right. Now we're going to add this move model. So I'm going to copy this over and then we can talk about it. So in the new app, paste this in, and then just so everything will work, I'm going to add this to validators. We'll talk about this in a second. So I'm going to create a new file called validators.py and shove that in. Okay, so what do we just do? Well, we created a new model called move, and most of this should be familiar. Like it's just got different columns, like name, accuracy, really nothing surprising right there. And then a couple, we're overriding this clean method. So clean is a built-in method that Django, actually we can, I'm gonna jump into the, should be able to jump into the source code here. I'm gonna go to model. Let's see if I can find model. Oh, models.base, DB. So I'm just gonna go find this in the source code real quick. Models base. Here's model base class. So this is a meta class. You don't have to worry about what a meta class is, but it's basically just a super base class. Let's see, where is the model? Here we go. So here is the model class, and we don't need to know anything about this, but I'm just showing you that you can look at the source code if you want to. So it actually inherits from something called alters data that we could look at, and then this model base meta class. So all of this stuff is basically going to be internal. So Django is doing all of this stuff internally. All you have to do is just describe what you want the model to be. Okay, so it's not obvious with Python if you're overriding a method, but you actually are overriding a method. Okay. Any questions about this? I think this is familiar.
I'm assuming you can create multiple model files inside your app.
You could,
Is that
yeah.
in practice?
I don't think that's really done. You can definitely create multiple classes like in the same file. So if you have model or move and then I don't know, like ability or something like that, you could have another ability model and just have that right here. But yeah, it's basically organizational preference. I've never worked on like a real large Django application before, so. But so some languages have a convention where it's one class per file. So if you work with Java or lots of other languages, that's kind of a rule basically. But Python doesn't care. So in Python, you will often have multiple classes in a file. Okay. Great. So now if I run this, I'm gonna update this stuff. Let's see. Migrations. Okay, so there's something new that happened. So we get a new, let's see, this migration file here. So it's adding this new model. And then to actually apply those changes to the database, we do the same thing. And if we could, if we went in and actually checked the database, we should see that table there. And it would be called something like move underscore app underscore moves or something like that. Okay. And we've got some tests here just to make sure this is working. All right, so I'm just going to run these tests. So Python image.py tests. Previous was test. Okay, so those tests pass. Notice that this output looks familiar. It's just the standard unit test output. So Python manage.py test is ultimately just calling unit test as the runner. And we can look at these in a sec, but yeah. So all we're doing is we're testing that this new model basically does what we expect it to. So we're creating instance, or we're basically inserting a row into move, and we're going to call full clean on it. And then if an error is thrown, then the test will fail. Otherwise, it's fine. So this is basically just testing, can you create a model? And you could obviously do much more sophisticated things. But here's an example. We're creating a new move. Here's the name, blah, blah, blah. So if we look at our validation split right. So for name, the validators comes from validate move name, which comes from here. So it has to adhere to this regex pattern. So does this adhere to this regex pattern? We need regex experts.
I think it's supposed to be just letters, so the 4 makes it not work.
Yeah, exactly. So this regex, what's this caret at the beginning? What is that doing? I don't expect anyone to really know this.
Does it mean
Is
not? I don't know.
Does it mean what?
Beginning of the, I think it's the beginning of the string.
Yeah. So a caret like here right there means like starting at the beginning. So a caret can also have another meaning depending on where it is, but in this case, it's starting at the beginning, and then we have the brackets, which means we're going to get like a set of possible letters. So basically this is so starting at the beginning of the beginning of the sequence, you can have a lowercase or uppercase letter. And then what is the plus?
Any amount of those letters.
Yeah, so it's one or more. And then we have a space and then a question mark.
Another optional amount of any amount of those letters.
Yes, so we have an optional space and then another, it's the same pattern as the beginning, right? So just one or more letters, and then what is the dollar sign here at the end?
Ending with, or
Yeah. Yep. So the caret at the beginning means like it has to start with this, and the caret at the end, or the dollar sign at the end means it has to end with this. So this validates, this should violate our validation rule. So we're going to call full clean, which basically means validate. And then, so this is kind of weird, right? I mean, we have this pattern over here as well, but why are we calling self.fail here?
If an integrity error or maybe a validation error is not thrown, then we're just going to say the test is going to fail, because in this case, we want it to throw a validation error.
Okay, good. Yeah, so can you walk me through, let's start with a valid model. So let's assume that new move is a valid model. Can you walk me through line by line what would happen?
If it was a valid model, we would test it, and so it wouldn't throw the validation error. So the try would keep moving down to the self.fail.
So okay, so we have a valid instance of move, which is like a row in the table, and then this line gets executed. And what happens when this line gets executed?
It would pass.
Okay. And then what happens next?
Self.fail would get called and it would fail.
Okay, cool, exactly. So in the case where our model is valid, we call this, and full clean is like, okay, yep, your model is good to go. We checked everything and it passes all the validation. If that is the case, then the next line gets executed, which will fail the test. Because in this case, we're expecting a failure. So now let's look at this case where we have a model that shouldn't pass muster. So what happens there?
During full clean, it would throw a validation error.
Yeah.
So it would step out of this one and go to the accept validation error.
Exactly.
Skipping the fail part of it.
Yes, exactly. So if this line fails, this line doesn't execute. So if this fails, we jump into this, and then in this case, we're expecting it to fail, so we get this message. All right, cool. Questions about that?
Yeah, so I know I had the issue with this like in one of the first couple of classes when we're doing the tests like earlier this week. So I get what you're saying, but I guess I'm having a hard time wrapping my head around it. So when you run the test in a terminal and it still gives okay, but yet you want the test to fail.
Yeah.
So
it is confusing because we're testing that it works. So we want to test two basic conditions. one, that a correct model gets created, successfully. And we also want to test that a bad model doesn't get created. So if a bad model, if we try to save a bad model, it should throw an error.
Mm-hmm.
So we have to test the error case, which is a little counterintuitive, but we're saying, like, if this fails, then it passes. Right? So it's kind of a weird thing, but we're saying here is a bad model. It should fail. We want this to fail. That's why we wrote the validator. We want this to fail because it doesn't meet our criteria. So when we try to save it, it should fail. It should actually fail. So it should throw the exception and it should go down to here. And then we can check the exception and make sure that the exception is the one that we're expecting. If it doesn't fail, if instead we give it a bad model and it passes, then well, there's a problem, because I don't want this. I don't want this garbage in my database. So if it doesn't fail, then we have a problem.
Okay. That makes more sense.
Does when it hits self.fail, does that just kill the test and then move to the next test?
Yeah.
And nothing else executes?
Yeah, it should just automatically fail. It should
Okay.
stop.
So is that why, like, if like where it has like the E and F in there, like would it be like F, like the test didn't run because like it never got a chance to assert?
Yeah. So for example, I'll just write a new test here. So assertion error, none. So I get the F here, the test fails. If I did something like wonky, I don't know, I should get an error. So I get an E instead of an F.
Okay, thank you.
Yeah, so there are a couple ways to do this. There's you can use a with and then assert raises. Yeah, this is just one way of handling the case where we're expecting an error or expecting an exception to be thrown. Okay. So now I'm gonna go ahead and go in here and see. I think I'm gonna add another. I'm gonna go back to the previous day. I think it might have. I'm gonna add a Pokemon and a move. Here we go. All right, so I'm gonna go into the shell, and I'm just gonna insert some data. I'll do that here. So I'm gonna have to import this stuff. I should just be able to do this. And I can check if it actually exists. Is this, can you guys read this? I might do this in the terminal here. I'm gonna do this right here. So Python init.py shell. Oh, whoops. So I just got an error. What should I do to fix it?
Maybe type pip list to see if.
Okay, yeah, that would be a good diagnosis tool. So pip list. So I don't have, this is kind of odd, but I don't have this thing. So I'm gonna do let's see, deactivate. So it looks like I'm in a virtual environment, but I might be in the wrong one. I'm gonna ls and make sure that I'm in the right spot first. Okay, this looks good. So I'm going to do source, then bin activate. I'm going to try running that command again. Okay, so now I'm in the shell. And I'm going to import. So from, I'll take that. So I should have a Charizard saved. I didn't come up with this, by the way. No. So let's see, Pokemon dot objects dot all. Okay, so we have saved something. We have this Pokemon object. Okay, so now we're gonna add a another one. I'm gonna go back to today's README. And I'm going to create a model. So I'm going to import the move model. That's over here. Okay, and then I'm going to create one. And now I should be able to do the same thing that I just did. So I should be able to go move dot objects dot all. This is like select star from. And I see I got this one. I could also, if I just, so when I do all, this is like select star or whatever, I'm getting multiple rows. So that's a query set. Query set is basically like a list. It's a list of rows. If I just want one row, I can do move dot objects dot get, and then I specify some condition. So for example, I can do ID equals 1 because I know that that exists. And I just get that one thing. So it's not a query set, it's just one row. So Django has its own very special way of like filtering if you use stuff like this. All right. So both these models exist independently. So now what we want to do is associate these things. So I'm going to go back to the Pokemon app models. And we're going to add another field here, which is going to allow us to connect to the moves. We'll import these two things. And then I'm going to add this. Doesn't really matter where we add it, I'll add it at the end. And then let's look at the clean. Okay, so we're gonna okay. So we have we're gonna override the clean method here, and we're just gonna do some extra validation check. Basically, we just want to make sure that looks like you can't have more than 4 moves. And what we're doing here is we're adding this models.many-to-many field. And you can look at the Django documentation. So Django actually has very good documentation, relatively speaking. And here we have many-to-many relationships. To define a many-to-many relationship, use a many-to-many field. So first off, how, if we weren't using SQL, or sorry, if we weren't using Django, if we were just using SQL, how would we define a many-to-many relationship between Pokemon and move?
You'd create another table to kind of route the two through.
Exactly, yeah. So we'd have to create a third table that could connect those. So we have Pokemon to move, and then we'd have like a Pokemon move table. We have to create a third one. So in Django, there are a couple ways to do this. You can actually create a third model, but you can also use this convenience right here, where Django will implicitly create that third table for you. So you don't have to define it. And you can read through the documentation for how to do some of this stuff. But the concept we're already familiar with. The thing that you need to like worry about is the specific way that Django does it. And that's mostly a look stuff up and play around with it. But the basic concept should be familiar. Okay, so we have created this, and what we've just done is we've changed our model, right? So we have changed our Pokemon model. And we've changed it in such a way that the underlying SQL table will have to be different. So what do you always have to do when you make a change like that?
Migrate.
Yeah, exactly. So Python manage.py make migrations. Okay, and if we look here, notice we get 002 on the Pokemon app. So we're adding a field called moves. So you shouldn't really need to worry about looking at these migration files. I'm just showing you for the sake of showing you. Okay, so that worked. Now we have to actually migrate. And you might have an issue depending, you might, if when you're migrating, you have issues, I would suggest just delete these folders and the database and then just redo everything. You can definitely, if you want the experience of trying to fight your way through migration, that's fine. But my suggestion would be just wipe everything and start over. So delete these like migration files and then delete your database and then restart the database and run the migrations again. It's definitely, it's a real world problem running migrations. I just, in my opinion, it's just not worth the trouble at this point.
So in that case, would you want to do all of your changes, and so you just do the one migration at the end, or do you want to migrate in steps just to make sure everything's working?
Yeah, that's a good question. It kind of depends on when you're doing it. So in an ideal world, you think through everything and you just have one, you have one migration. You design everything perfectly and then you migrate once and that's it. But obviously that's not how it works in the real world. So the pace of your migration, the pace at which you update or change your database schema is going to just depend on whatever you're doing. So it basically becomes similar to like a code change. So if you find a bug in the code, well, you fix it and push up a commit and run it. If there's a large feature that you want to add, you probably want to make sure that the whole thing is working and then you push it up once the whole thing is working. So it kind of depends on what you're doing. Okay. All right. So we ran the migration. So I'm going to go ahead and I'm going to go into the database again, and I just want to make sure that worked. So I can describe the tables, and we have app move, and we have Pokemon app. So here's our initial one, Pokemon app, and here's the one we added, the move app. But now we have this other third table. And by the way, these ID sequence, this is the auto incrementing primary key, so you don't have to worry about that. You can ignore those. But yeah, the Pokemon app Pokemon moves. So we didn't create this table. Django did it for us, and this is what I decided to call it. So even though our code, it looks like we just have two models, we have Pokemon and move. Because we use this many-to-many field, Django did some magic under the hood for us and created this join table. Okay, again, like conceptually, that shouldn't be new. It's just, this is how Django works. All right. So now I'm going to go into the shell here. Oh, Q/Q. I'm going to go to the shell, and then I'm going to import some stuff. And import some stuff, and now I'm going to create a Pokemon, a new one, and save it. I think I already had this one saved, but let's see. So let me just see how many Pokemon I have. I suspect that I have 2 now. So Pokemon dot objects dot all. So I have 2 Pokemon. Are these identical?
Their IDs will be different, right?
Yeah, exactly. So if I do Pokemon dot objects dot get ID equals 1, I'll get one thing. If I do 2, I'll get something else. If I do 3, I will get an error. All right. Okay, so I basically just gave these a name. So I have a Pokemon and a move. So now what I want to do is I want to associate. So first off, I'm going to do Pokemon 1 dot ID. I can do Pokemon 1 dot name. And let's look at the model real quick. So I am on, okay. So I have name, level. So all of these fields, I can access them as though they were just fields in an object, right? What about moves? That one's a little different. So all these other fields, I can access them as though they were, just regular primitive values. This moves is a little different. Notice that the name of the object is a create forward many-to-many manager. So it's a bit weird. So we'll look at how we handle that. But I'm also going to do the same thing with move. So move 1 dot name. And is there a way to go from a move to a Pokemon? Something. Yeah, so we'll have to come back to that. So now what I'm gonna do is I'm gonna add this. So Pokemon moves dot add. So notice we did Pokemon dot moves. We got something, but it wasn't just a regular primitive value. Like you might expect. It's something else. It's that forward relation, blah, blah, blah object. Forward, blah, blah. Okay, so that gives us the ability to do some other stuff. So I'm going to do Pokemon moves.add. Sorry for all the switching here. Okay, so I have this manager thing. So this is a Django, a Django thing. We have these manager classes, and if I do Pokemon.objects, that's also a manager. So you can think of these things as being like, how do you call it? Yeah, it's just it's an interface that allows you to do all the operations that you would expect to be able to do. So we have this manager here, like the normal manager, and then we have this many related manager. So if we do Pokemon moves.add, we can associate a move with this Pokemon. So move one. And now when I do Pokemon one.moves, what am I going to see? Still that create for blah, blah, blah manager thing. But I can do all. And now I can see all of the moves that this Pokemon has. So this looks similar to Pokemon one.objects.all. It's the same kind of syntax and it's the same kind of result. But here, we're not using the Pokemon built-in object. We're using this manager. We're using this many-to-many thing. So this is just Django magic. It's how it works. It's a little weird. You just have to, you just have to learn how Django does it. The Pokemon one.moves.all. So that is how, yeah. That's basically it. You can dig through the documentation. Let's see. So another, there's some customization that you can do that we're not really going to talk about right now, but you can absolutely look into it. This is another quirk about the many-to-many relationship, how Django handles it. We have this article set, for example. So we talked about the reverse relationship. So I can look at the object. I can look at the Pokemon object and see that it has moves. And I can directly access Pokemon.moves. But when I look at the move object, I don't see Pokemon anywhere, right? There's no obvious way to do that. The way that this works is you do move dot. Actually, I think I have to have a particular one. That Pokemon set dot all. So it's, again, this is just how Django does it. It's a little odd, but you have move one and then Pokemon, whatever the thing is, underscore set. And that's how you get that reverse relationship. That's how you go from move to Pokemon, even though you don't see Pokemon on the move model. So that's a bit weird. Again, this is just, Django is pretty, I would say pretty like straightforward and like consistent, but the many-to-many stuff is weird. Okay, that's basically it. So that's how you create model. And there's, foreign key. So if you want a one-to-many, that's called foreign key. And a many-to-many is called many-to-many. That's pretty much it. Does anyone have any questions? All right. I will let people decide if you want to work individually or in groups. I'll just open up breakout rooms. I'm not sure what is going to be easier just because it's based on previous challenge. I also am curious